Okay, folks, I think we now have it working, I hope, and you should be able to see this. You should be able to see this both on Zoom, and also it should be coming through clearly on the stream now. So if you don't want to continue watching on the stream, that's fine. Now what I'm going to do is switch to the other computer and go to the lecture. And what my plan for this lecture is to allow you all to be quite interactive and guide me through what you want to cover in the lecture. Okay, so more so than normal. In fact, if this works well, we might try and use this setup in future lectures. So hopefully you can all see now. If you're watching on the live stream, you can see my screen, and if you're on Zoom, you can also see the screen. And if you want to ask me a question, you can just yell. Okay, I will put the Teams chat somewhere where I can read it, but I'm going to mostly just respond so I can focus on the exam. I'm going to mostly just respond to your own questions. So let's get going. The plan for this hour is to go through questions in the mid-semester exam. The first thing to point out is I made a repo of the mid-semester exam for everyone on GitLab. So you'll find it here. I just cloned it into my own area, but you'll find it in the COMP1110. COMP1110. You go here, and you'll see it. Mid-semester exam is there, and in there you'll get all of the questions for the mid-semester exam that you just had. Oops. So what we're going to do now is go through some questions, do one from each. There are multiple choices here. I think you should see this as a really good resource for practicing. So you can, each of these is basically very similar, but with a small variation on each one. So I highly recommend you save some of these and do them later, and try to get through as many of the others as you can, as soon as you can, so you get a good sense of where you're at. Now, has anyone got a particular preference about which one they wanted to start with for the very first question? The dumb thing to do is just start with the top one, but I can do a different one if someone would like. Oh, what's going on here? Oh, I already wrote an answer there. Let's not look at that. I did that already when I was... So has anyone got a... has anyone got a suggestion? We won't do above. It looks like I've already written an answer in there. Should we do below? Any objection? If someone would like to do a different question, please yell out. And what I really want you to do now is to jump in here and yell on Zoom with any feedback you might have. So I can... Someone said some. Okay. It might be better for this lecture if you use voice rather than chat. A, because there's latency there, and B, because it's hard for me to read that over there. So that'd be great. Well, I'm happy to do some. So let's look at some. All right. So let's start with this question, and let's look at what the question says. Right. So we're going to step through this slowly, but we're going to try and step through it like you would an exam, and I'll try and encourage you to think it through the way I would encourage you to think it through in an exam. Okay. So compute the sum of every fifth element in the provided array, starting at element 0. If the array is of size 0 or is null, return 0. Okay, first thing to notice is that you've got this thing here. It says if it's size 0 or null, return 0. So what we can do is straight away write that. Let's first of all run the test. Hang on, where was it? Let's put this back in there. Make sure the test, where is it, sum? All right, so let's run this, and should give us fails on everything, right? Oh, what's happened here? Missing, oh. There's another error here. Sorry about that, folks. I thought this was all clean. I must have a few little errors in here. Okay, good. All right, so we failed all the tests for some. That's what we expected. All right, so let's go through some. And what I said was the first thing we should notice is that we've got this special case here that says if the array is of size 0 or is null, then return 0. Now, I'm really encouraging you all to jump in and make suggestions about what I should do first. But what I'm going to do is to try and get some marks quickly, because we're in an exam situation. We're going to write those cases in straight away, right? So if the array is null or size 0, so let's say values equals null, right? And then we're going to return 0, 0 like that. So just leave it like that, and then what we can do is we can run that, and you'll see straight away we get 1 mark. But we can, there you go. So we've now passed 1 test, and now we can increase this and say if the, what was it, size 0, values.length is 0, then it returns 0. Okay, and just like that, we're going to get ourselves 2 marks. Bang, we're 2 marks. We're off and running. So now what does it say? It says sum every 5th element in the array. Okay, what do we need to do that? All we need to do in this particular example is add stuff up. So let's create ourselves a sum. Now, if there was nothing in the array, well, we've already covered that case, but we'll start off with the sum being 0. And then what type is it going to be? Well, it's going to be a double. We've got to return a double. It says up here it's got to return a double. So we'll make ourselves a double, and we'll just call it S to keep it short, and we'll just initialize it to the value 0. Okay, so there's initially nothing in there in that sum. Then what we need to do is we need to loop over this array, and we need to keep going over the array, how every 5th element. Does anyone know how to do that? Does anyone want to offer a suggestion on how we do that? How do we get every 5th element? Anyone? Well,
by 5.
Yeah, great job. Yeah, increment by 5, right? So we're going to say we're going to go over the array until we get to the end of the array. So it's values.length, right? Length, and then we're going to say increment I by 5, right? Not by 1, but by 5. So we skip every 5th one, and then we'll say S plus equals values I. So what this is going to do is going to go through every 5th element and add on to S. Oops, typo. I'm still using my yucky keyboard here. Don't do that in an exam, folks. It will slow you down. Okay, so there we are. And now what we're going to do is return S. And now let's run our test like that. Okay, and we've got ourselves 5 marks. All right. So we just looped over the array and we skipped over every 5th one using this. And the important thing was it says starting at 0 here. Right? If it said start at 1, we'd have to do something like this, you know, start at 1 or something, but it didn't. It said start at 0. So we're all good. Okay, what would people like to do next? I'm sure someone said in Piazza what they wanted to do, but I'm afraid I've been absolutely flat out and I've forgotten what everyone wanted. Some of these questions are a tiny bit harder or easier, but I can do outside if you really want. Let's do outside, okay? Should we do outside? Someone suggests this one's harder, so let's do a harder one. I'm okay with that. All right, you want me to do that? Let's do that. We'll do this, and then I want you to tell me which question 2 you want to do. Okay, let's quickly do this one. All right, so first of all, let's play the same trick. If it says if there are no elements to average, then return 0, or if the array size is null, right? So let's do this. So I think sum probably was the absolute simplest question in the whole exam. So I think the person who said that is probably right. So we'll say if, so I'm afraid I'm struggling to keep, okay, so let me go back. So I think someone's asking a question about this one. I'm just going to jump back there, but try and use the audio if you can, because it's kind of really hard for me to do 2 things at once. And I know some of you complained about that in the exam. So what was the question? Why would value 0 not be the same thing as values.length minus equals? I don't understand the question. Sorry, can you, could you say, Stephanie, could you say it out loud what you're asking about? Are you asking about line 18 here? In sum, line 18, is that what you're asking about?
Sorry, the minus sign was a typo, but what I'm asking about is the syntax for the values.
Yep. For here, for this line here, line 18?
No, in the if statement, line 13.
Oh, up there.
Yeah.
Okay, right. So this here is saying how long is the values array. Okay. Now, if we go like this and put a square bracket there and put some value like 0, that's going to say what is the 0th element of the array, which is a different thing. Okay. So value 0 will tell us what the 0th element of the array is, which is not a reason to return early in this particular question. Okay, so there we're just asking what the length of the array was, and that's what array values.length is. Whereas if I put 0 in a square bracket, that's telling us what the value is of the 0th element of the array, if that makes sense.
Yeah, thanks. I thought they were synonymous, but they're not.
Yep, okay. All right, so now let's go to outside, because someone asked about that.
Steve,
yep.
just before you jump ahead, do you want explain why it's really important to put the null condition first, because a few
students
very good. Caught up on that in labs.
I recognize Ash's voice there. Thank you, Ashley. All right, so notice here, this is a really good question, really good point. So notice that there's two conditions here, right? And so I could have put values.length here, right? Values.length equals 0 first. I could have done that first. However, if I did that, the problem is if values was actually null, then values.length would give an exception. Okay, so let's actually try that. Let's just quickly see what happens if I do that and then run the test. Well, let's just leave it like that and you'll see what happens anyway. It'll show the same problem. If I run this, look. Oh, I'm in the middle of writing that code there. Okay. Let's run it again. Okay. Sum test. Okay, we should get a null pointer exception this time. Yeah, null pointer exception. And the reason is the thing that Ashley just raised, okay? And that is that this test for length will not work if values is null. So we need to test for values first. And you can do it this way. The more obvious way to do it is this. Right? And it should be obvious to everyone that if you do it that way, that it won't do this if values is null. But the way I wrote it before is a shorthand version, and because this is the way I wrote it before, because what Java does is if that's false, then it doesn't bother doing the rest of the line. So you're safe to write it this way because it won't get a null pointer exception on this, because it won't do this at all if that part already fails, right? Because it knows that if this fails, the whole thing must be false, so it just jumps straight to the end. Okay, so that was a trick. It's an important trick, and so thanks for asking that. Let's quickly skip on to outside. I'm going to do this really fast because someone asked me to do it, but I don't want to spend too much time on this because I really want to move on to the other questions. Let me run that test again to make sure they're all happy. All right, so now we're doing outside. So let's first of all do the same sort of thing. If, what is it? What does it say? If the same thing, we want to see if it's not null. So we say values, if values equals null, right? We're going to return 0, just like before. Or if the length of values is size 0, then we also want to return whatever it says, return 0. Okay, so we do that first. We do that straight away and get ourselves. I'm trying to teach you to be strategic here, folks. So you do this straight away and you get yourself a mark or so. All right, there you go. You got 2 marks straight away, just like that, for writing that bit of code. So look for the easy things first. Then what does it say? It says average. Take the average of the ones that are outside of a specified range. So it means that if the value is higher than high or lower than low, then we want to include it in the average. Okay, so to calculate an average, what do you need? You need 2 things. You need a sum and a count. So let's just write that out now. We'll say int sum equals 0 equals 0. Int count. Count's going to be double. Sum's going to be a double though, right? Because we're going to have to return a double at the end of the day. So let's just do it like that. Int count equals 0. Now what we're going to do is loop over the array and put into our average the things that satisfy the criteria for the question. So we'll say for int I equals 0, I is less than the values.length. So we're going to go through every element in the array. And we're not going to skip to every 5th one like we did in the other question. Here we have to go through every element. And then at each element, we're going to say, is this value one of the ones we need to include in our sum? And what's that criteria there? We're going to say if values square bracket I, so that's the one we're looking at, if it's less than low, and or it's values.I is greater than high, either of those criteria, then we need to increase our count and increase our sum. Sum plus equals values I, like that, and count plus plus. Okay? Now, what do we return at the end here? Well, it says if there is nothing outside, then we return 0. Otherwise, we return the average. So we just say here, we can say return if count equals 0. We didn't find anything. Then we just return 0. Otherwise, we return else return sum divided by count, right? That's how you do an average, just the straight maths of doing an average, right? So let's just see if that works, unless I made a mistake. Hopefully we got that through that one. Great. Okay, question 2. What do people want? Or if you have any questions, fire away. But otherwise, well, let's move on to question 2. Question 2. What do people want to do for question 2? I can just do bus if you like. If I didn't, unless I already accidentally answered that one. I didn't mean to do that. All right, so let's just go through bus. Unless anyone objects, if someone wants a different one, go ahead and yell. Let's go through this. Okay, so what we've got here is it's got a bunch of things here, and it's got a bunch of little fix me's. Okay, fix me A, B, C, blah, 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 down to F. Let's just do them in order, okay? We're in a rush. We're going to go through this thing. We're just going to do it in order. Okay, so let's just read this. It's a constructor. It takes a number and speed, and it's got these fields up here, number and speed. So let's just do the basic thing for the constructor. Okay, so you should all know this stuff back to front by now. Okay, this dot number equals number, and this dot speed equals speed. Whoops. I'm not sure if we're going to get through any tests that just by doing that. Equals speed, sorry. There we are. That may or may not get us any tests yet. So get a bus. Okay, there we are. Bus test. It probably doesn't pass any tests. Oh, yes, it does. We already get 1 mark. Yay. We're already at 6 marks, folks. All right, so now it says return the speed of the bus. Now, the speed of the bus is a field. It's this field here, okay? So all we need to do is return speed. Okay? So speed is one of the fields of the bus. So all we're doing here is getting that value and returning it, okay? And then here it says set the speed. That's the reciprocal, right? So now to avoid confusion between that speed and the speed of the bus, we say this dot speed equals speed, okay? And then min to go. Calculate how many minutes it will take to travel to the remaining distance, assuming the bus maintains that speed. Notice that it says minutes, and the speed is in kilometers an hour. Okay, and it says it very clearly. The distance is in kilometers. Okay, so we're going to take in a distance. So it's got that far to go, distance in kilometers, and that's an int. Okay, so it's that many kilometers, and it's going to go at a certain speed. And we've got to do 60. There's a little trick here which is important. Okay, so let's do the simple thing to do would be to say what? Distance divided by speed, right? But we've now got to account for the fact that it's 60 times because it's minutes, not hours. So what we're going to do is we're going to multiply by 60. But where do we do that? Well, it's actually quite important that we do it here. Why? Because otherwise we'll get ourselves, this will be integer division here. And it would turn out to be, if that number was small and that number was high, it would give us 0 every single time. Okay, so we've got to multiply by 60 first, and we return that. Okay, like that. Okay, let's just run these tests. Okay, so we're through that. Now we've got to do, let's do this next one. The next one's an interesting one, and I think this is one that people found most tricky. So let's go through this. Return an array of buses. So we're going to make an array of buses, right? Given the provided numbers and speed. So someone's given us numbers and speeds. Remember, these buses have numbers and speeds. Okay? Or null if the length of the provided arrays do not match. So we've got 2 arrays here. If their lengths don't match, then we've got to return null. Or if there's nothing in these arrays. Okay? So let's do that part first. Did someone ask a question? Just feel free to butt in if you have a question. Okay, so if numbers equals null, or speed equals null, or numbers equals dot length is 0, that means there's nothing there, or numbers dot length doesn't equal speed dot length. All right, they're all the conditions for which we cannot do this, which it tells us not to do this. Okay, under all those circumstances there, we return, what does it tell us to return? Return null. Okay, return null. If any of those things are true, we return null. Otherwise, what do we have now? We have 2 arrays. We have an array called numbers and an array called speed. They're not null. We've already just checked for that. They're not 0 in length. We've just checked for that. And their lengths are the same. We've just checked for that. So now what we have to do is create a list, a new array of buses, and create all the buses in that array such that their speeds and numbers are the ones given. Okay? So we've got to make all these buses. Okay, first of all, we create the array of buses, which won't have any buses in it yet, but it'll be an array of buses. So we'll say bus, what is it, Q2 bus, like that, buses, like that, equals new Q2 bus. So we're creating ourselves an empty array of buses, okay? And how long is it going to be? It's going to be the same length as numbers and speed. They're both the same, so we can use either. We can go speed.length or numbers.length. It doesn't matter because they're the same length, okay? So you can just go like that. So now we have an empty array. What do we need to do now? We now need to step through the array, and for each element of the array, make a new bus. And that bus is going to have the speed from the speed array and the numbers from the number array. So how do we do that? We have to write a for loop. Okay. Hey folks, please ask questions. I was really kind of hoping for this to be a little bit more interactive. I realize you may not want to ask any questions, but I'm really encouraging you to ask questions or butt in to make suggestions on how to do this. Like watching me make a typo like I just did there. Int I equals 0, I is less than buses.length. Here, of course, we could say buses.length, speed.length, or numbers.length because they're all the same, right, at this point. And now we say I++. So now we're going to go through here and we're going to make a whole lot of new buses, and we're going to assign those buses in the constructor the speed from the speed array and the numbers from the numbers array. Okay, so we'll say buses I equals new Q2 bus, and then we're going to say what? A number and a speed. So we say numbers I, speed I, like that. Okay, does everyone, that make sense? So we've created a bus here, and it's going to take its number from the numbers array, its speed from the speed array, and we've put it into the buses array. Okay, and then we just return that. Okay, so we've done that. Next thing we're going to do is do this toString method. This should be very familiar too. We've got to do it in exactly this format here. Let's just cut and paste to make sure we get it right. We do cut, and then we'll say paste here, like that. And now we're going to change this number to be whatever the number is. Number plus number. Oops. Number. And then IntelliJ is not being as helpful as it thinks it is. All right, there it is. And then the speed, same deal. We'll say plus speed, like that. Okay, I think that's right. And we run this bus test, and hopefully we're done. Yeah, okay, great. Any preferences on which one we do out of question 3 now? Please speak up. I'm really...
Probably squares.
Can we do magnets?
Squares or magnets? We need votes here, folks. Any preference? Squares and magnets are the two. There's magnets, there's squares. Does anyone have a strong preference on this one?
Magnets, please.
Which one? Magnets, is that what you said?
Yeah.
All right, let's do magnets. I don't really mind which one we do. So we have 2 votes for magnets and 1 vote for squares. We'll just do magnets. Hopefully no one's too offended. They're actually quite similar. They're different, but they're similar questions, okay? I did that very deliberately with each of them. Okay, so they're different, but very similar. And hopefully you notice this is very similar to what you had to do in assignment 1. This was not supposed to be this is not supposed to be unfamiliar to you. It's supposed to have a familiarity because this is very similar structure to assignment 1. So we're gonna do this piece placement. Okay, so what does it say? A problem is concerned with the placement of pieces in a simple puzzle played on a 4x4 board. Okay, that's important. There are 5 piece types. Okay, typo, that should be 4, obviously. Okay, there are 4 piece types. You can see there are 4 there. Okay, I didn't notice that until just now. There are 16 piece positions, and notice they're written 0, 0 all the way up to 15. There are 4 orientations, north, east, south, and west. That should be all kind of familiar stuff to you. You've seen orientations like that before, and you've seen these ideas of having different piece types before. Okay, you're advised to implement the missing code in the order given. Be sure to take into account the piece orientations here, okay? So return true if the piece string represents a well-formed piece placement, okay? To be well-formed, it's got to have the following. Okay, first of all, it's got to have, so it's got to have a letter describing the piece color. So one way we can do this is we can just write a simple if statement that checks that, okay? So if, where is it? If, so we need to check if the piece at character 0 has one of those letters, all right? So we can just, there's nothing special about those letters. They're it's white, black, orange, and pink, I guess, or purple, right? There's 4 colors. So So what we need to do is check individually. I mean, that's the simplest way to do it. We can do fancy stuff, but now we're in an exam. We're just going to do it the simplest way possible. So we're going to write piece.char at 0 equals we'll write out what they should be, and then we'll put a not in front, okay? So we're going to say if it equals W, like that, or, and then let's do cut and paste and make this fast, like this, and we'll cut and we'll paste it in 4 times, like that. W, what's the next one? B, white, black, oops, B, typo, black, what's it? Orange and purple. All right, or pink, there we are. So there's our 4 colors. Now, that's actually what we want it to be, right? So we don't want to return true just yet, but we'll put a negative in front of that saying, if that's not true, we're in trouble, right? So we'll return false. Okay, all right, so we're going to return false, right? So that's one condition out of the way. The next is we want 2 digits. Let's first of all check simply to see if the digits are there, if they are actually digits, or we can do, there's a number of different ways we can do this, but one simple way to do it is we can just check those 2 things to see if they're actually digits, okay? We can say if piece char at is, oops, oh goodness, keyboard issues again, is greater than or equal to 0, like that. If it's not that, and it's not greater than or equal to, less than or equal to 9, then we've got a problem. We need to exit, okay? There we are. Okay, so if these 2 things aren't true, then our thing doesn't match and we've got to bail out, all right? So like that. There are many ways to solve this, by the way, folks. Please, one of the reasons why I wanted to use Zoom was to get you guys to interact so we could do this different ways. I'm just doing stuff as I think of it right now. This is not necessarily a good way to do it. It's just one way to do it. And when you're doing the exam, you're not looking for the perfect answer. You're looking for an answer that works and that you understand so you don't get panicked, okay? So this is really, really simple. I've just said that character's got to be in that range. That character's got to be in that range. The next thing is it's got to have a letter describing its orientation. That's a lot like this. So let's just cut and paste this code because we're in an exam and we're a little bit panicked. All right. And then we're going to say if char at, we've got to make sure we don't make any typos here. We're going to say north, east. Now I've already made a mistake there. South and west. And we can return true here instead. Like that. Or whatever. Let's just leave it like it was. Okay, there's lots of different ways to do this. One way to do it is like this and then return true at the end here. Whoops. True.
Steve.
Yeah, go ahead. You frightened me. You're very loud. But go ahead.
Sorry. First of all, shouldn't it be less than or equal to 9? Is it greater?
It should be. Yes, thank you. Well spotted.
And second of all, should the all be an and instead?
You're absolutely right. Okay. Okay, this is why we're on Zoom here, folks. Let's just ignore what you said for a minute and run the test and debug it, right? Because not everyone's going to write perfect code first time through, right? You're well spotted, but I would have made those mistakes and I've run the wrong test. Which one are we up to? We're up to magnets. Let's run the test for this. Q3 magnets. Where is it? Magnets. And it's not going to work for the reasons we just heard, okay? Let's have a look here. And you'll see here that this returned false. Okay, and it returned false. And we look here and the reason we can go through and debug this. It's a bit hard to now. We've already heard the answer, but basically the problem was that should have been an and. All right. Okay. We want it to be inside that range. We could have written exactly the reverse. It might have been simpler to write the reverse. We could have said, actually, let's just do that for the sake of everyone's clarity. I think the code reads better if we do it the other way. So let's do it the other way. And if you're watching the video, you can see. Ooh, come on, IntelliJ.
Steve,
Yeah.
the test that failed was about the first thing.
Oh, was it? I'm not even reading the tests. Don't do that in the exam, folks. Okay, so hang on. All right, so this is another way to do it is like this, okay? So I've changed the test now so it says that if it's outside the range, return false. Okay, where was that? Oh, we didn't do the test of the length of the string. My goodness, that's bad, right? Okay, so the string here is 5 characters long, and that's why we failed. It must contain exactly 4 characters. Folks, I just made a huge mistake, right? When you do your exam, remember I made a point of this in the previous questions. Find the things really simple and make sure you test for that first, okay? So here, if piece.length is not equal to 4, then definitely return false, okay? Not equal to 4, then return false, okay? So you always want to, I'm trying to teach you good tactics for the exam. If you see something like this, must contain exactly 4 characters. If it doesn't, then return false straight away, okay? So I should have done that at the beginning. All right, and now, okay, so we've got that working. All right, so the next one is well-formed puzzle string, and then we've got get adjacent. So well-formed puzzle string. So in here, what we're going to do is, what have I done? Sorry, I've accidentally jumped into the wrong file. Magnets, there we are. So well-formed puzzle string. Now let's be systematic, like I meant to be there. It's got to be comprised of exactly 16 well-formed piece placements. Okay, so let's bail out if it doesn't, right? So we'll say first of all, it's got to be the right length, right? So if puzzle.length is not equal to, and if we're really panicked and can't even do our maths, so we can't remember that 64, we can just write it like that, okay? If it's not equal to that, 16 times 4, right, which is 64, then return false, right? Okay, well-formed puzzle string. Yeah, I should check for null first. Puzzle string must be comprised of, yep, so I should check for null here first. Like that. Like that. Okay, so we check that it's I should probably do the same here too. It didn't actually ask us to do that. We may fail the test if we hadn't. Okay, so it's got to be, well, obviously if it's null, it's not what it's asked for, so we should definitely check for it. Okay, so it's 16 well-formed piece placements. So now what we need to do is we need to write a loop that checks that each one of these is well-formed. Okay, so let's do that. So for int I equals 0, I is less than the length of it, puzzle.length, right? I plus equals 4, because each one of these is 4, right? Plus equals 4. So we're going to loop through this thing like that, okay? And then what we're going to do is we're going to make sure each one of these substrings is well-formed, is a well-formed piece placement. So we'll call out the substring. We'll say string P for piece equals puzzle dot substring I comma I plus 4, right? And then we'll say if that substring is not well formed, if not was it well formed piece? Hang on, which one is it? Piece placement, right? If it's not a well formed piece, that one for this piece, then we return false. Okay. So that way we've now returned false, right? So now we've checked each one of the substrings. Each one of the 4 pieces has now been checked. Now at this point, you now know that they're all good. But what else it says is there's got to be 4 pieces of each kind. There are lots of ways of doing this. Okay, so one way to do this is to say that we could how many kinds are there? There's 4, right? W, B, O, and P. So one simple way to do this, there's many ways you can do this, but we could write ourselves, if we just think really quickly, we need to have 4 counters, one for each one of those 4, right? We can do that in an array of ints. So int array, we'll call it counts. Counts equals new int 4. There are 4 of them, right? And then we can just give each one a number, okay? So now we can go through here and we say C char C equals P dot substring dot char at 0. Okay, that's the piece type, right? Or the color, right? That's the color of the piece. And then we can say if C equals white, then counts 0 plus plus, like this. So we're going to increment the count according to which color it is. Else if C, and now let's cut and paste because we're we want to be nice and fast, so we go like that. Black then counts 1 and so forth. Okay, and then we say else if, I missed out parentheses there. Okay, we do it like this. If it's, I was an orange and pink, I think. O, and then we'll make this 2 like this, and then we'll say else if pink, then 3. Okay, now what we can do at the end is we can just make sure all of those are equal to 4, right? That's what it said. Exactly 4 of each kind, right? So now we make sure at the end, we'll make sure they're all 4. Okay, and they've got to make sure there's no overlapping ones. So for that, we can do something similar. So what we can do is we can make an array of all the positions, and if someone tries to put somebody in the same position twice, then it's gone. Okay, so we'll say Boolean taken equals new Boolean. And how many are there? It's 4 by 4, so 16 like this. And then what have I done here? Boolean, new int. That's not going to work, is it? It's got to be Boolean, of course. Right, that. So we're going to array Boolean. Oops, typos everywhere here. So we're going to array Booleans. They're called taken. Now what we need to do is extract the number. Luckily, we know that it's well formed, so we know exactly what we can extract. So now what we can do, we can say int. What are we going to call this thing? Position. Call it pos equals integer dot from parseInt. Is it parseInt? Yeah, parseInt. And then we're going to take, what is it, the second part of the piece. So it's piece dot substring starting at 1. They start at 0, comma. It's 3, right? Like that. It's like that. So that's a position now. Now what we'll say is if taken pos, then return false, because that means someone's already taken it, right? So we're done. False. Like that. Else, otherwise we can just say taken. We don't even need to write the else case because it's implied, otherwise you've returned from the method. Pos equals true. Okay, so now let's try equals true. So now we've filled the array in to say that, and if we get through all the stuff, we're actually all good to go. Right, so now let's run this, the magnet test. And what's happened here? Assertion expected to get true but got false for this one. Where are we? What did we do? We just broke this. If piece is equal to null, right? That was our problem. We added this bit of code in here which broke everything. All right, we said return false if it's not equal to null. We'll say return false if it's equal to null. That's 1. Here, what's the problem? Null pointer exception. Here, line 52. What's that? Line 52. Puzzle is not equal to null if puzzle is equal to null. I've done it exactly opposite twice now. Okay, there we go. Try that again. So I made those multiple mistakes. Hopefully you see I make lots of mistakes too. Okay, we got through everything. Now we've got to do adjacent. Okay, what's the adjacency thing? Return the position that is adjacent to the given side of the piece where the piece is in a particular orientation. Okay, so here your piece is going to be in one of these positions, and we've got to say that's the adjacent one for a particular side. And there are 4 so-called sides, okay? 0, 1, 2, 3, 4. Okay, and assume the orientation is like that. So it's going to multiply. So if it's pointing up, then the top is up there. But if it's pointing that way, the top is actually that way. So we have to add these things on, okay? So how do we do that? Can anyone suggest how we're going to do that? How we're going to find out what the actual position is? How we're going to get these things to work together? Anyone know? Int direction equals what? Anyone? It's equal to side plus the orientation with an integer remainder of 4, because it's going to be like a clock. It's just going to keep going around. Okay? Just think about that. If you don't understand what I'm saying, either ask me a question or just think about it for a moment. Okay, that's the direction we're really facing. Okay, if you take the side, which is one of these ones, so it's top and you're upright, then it's 0. If it's right and you're upright, it's 1. If it's right and you're rotated 90 degrees, it's actually down there, it's 2. Okay, so we get that. And then what we need to do is we need to say, there's many ways to do this, but one way to do this is with the switch statement. So we can say switch direction. Okay, now what we need to do is we need to get our new position. First of all, let's find out what row and column our current position is in. So we can say int r equals the row. So we take the position. How do we get the row? Well, we divide by 4, integer division. Position divide by 4. And the column, integer remainder. Like that. Okay, that's our row and our column. And now what we want to do is, depending on what direction it is, we're going to do a different thing. Okay, now, first of all, let's consider if we're going up. There's only 2 cases here. Either we jump up a row, which means subtracting 4, or we're off the board, in which case, what does it say to do? -1. Okay, so case 0, we're done. We can return one of 2 things. If we're in row 0, r equals 0, then we return -1, because that means we jumped off the board. Okay, otherwise we return our position up 1 row, which is -4, right? Like that. And then we can just repeat this 4 times over, like that. So then we've got case 1. Case 1 is going to go to the right, case 2 is going to go down, and case 3 is going to go to the left. So let's do this one. So let's do case 2 first, because it's in the vertical direction as well. So if we're going down, we say if the row is equal to 3, then we return -1, because if we're in row 3 and we go downwards, we're off the board. Otherwise, it's position +4. Oops, +4. Right? Is that right? Yeah, I think so. If it's 1, it means we're going right. So now we're concerned with a column. If the column is equal to 3, then we're off the board. Otherwise, it's position +1. To go rightwards 1 is to go +1 in that graph, in that grid. Okay, if the column is equal to 3, that means it's a 0, sorry. I could have done this the other way around. Sorry, if we're doing case 3, it means we're moving left. So now we're concerned with being in column 0. So we're in column 0 and we move left, then we're off the board. Otherwise, we're in position -1. Okay, and then we've covered all the cases, so there's nothing else to consider, but we can return -1 here anyway. And let's just test that. Okay, and we've finished that question. Okay, so what would you like to do? We've got enough time here. I'm happy to go and do the last question if anyone would like to go at one of these. Shall we do, I don't care which one we do. Does anyone have a preference for which one we do?
May I have a question?
Yeah, sure, shoot. You can ask questions.
In task 2 and task 3, related to the test didn't check if the position is within 0 to 15, right? I mean, in question 3 magnets, in the second question, to test if the piece is valid. We didn't check if the
yeah, I did here.
Between 0 and 15. So if we
like you're right. You're absolutely right. You're absolutely right. I skipped that, and the test didn't show it up. But what would have happened if I had is we would have got an exception here, right? It would have been out of bounds on this line here. You agree?
Yeah.
So what we can say here is if, well spotted. Okay, so if pos is greater than 15, then return false, right? Now that goes.
Yes.
Okay, so what you just discovered is that test didn't cover one of the important cases. Okay, well done.
Yeah.
Any other questions before we move on, if you want to move on? Should we go and try the last question? I'm happy to do either.
The tunnels?
Sure, let's do tunnels. Okay, we'll do tunnels. All right, so concern with a game played on a square grid. Interesting here is it's any size grid, okay, n by n, where the position is occupied by one of 4 tiles. Each has 2 tunnels that serve as exits. Okay, see if you can mentally visualize this. You might want a piece of paper if you're trying to do this yourself. You might want a piece of paper. Okay, this is kind of interesting. So one of the 2 tunnels goes in the vertical direction, up or down the board, while the other goes in the horizontal direction. So if you're on a position, you can go either up or down, not both. One either up or down, and you can go either left or right. Okay, and you can only go in one direction. You can't necessarily come back in the same direction. It's possible that the other place you got to has one that takes you back, but that's not necessarily the case. Okay, so let's have a look here at how it works. So for piece W, if you get in the vertical direction, you go 1 square up with the W, so the tunnel goes up 1 square, and the horizontal goes 1 square to the left, okay? For X, it goes 2 squares down, Y goes 3 squares down, and in the horizontal, it goes 3 squares left, and so forth. Okay, you get the idea? And the boards look like this. And it gives you an example there. It says, if the W tile was in position 5 in the 4x4 board, there it is, okay, then it could reach position 1, which is marked V below, right, there it is. It can go up to there via its vertical exit, and position 4 by its horizontal exit. That's because W is 1 square up or 1 square left. Okay, everyone get that? Okay, so given a board, starting position and a Boolean stating whether movement is vertical or horizontal, return the position directly reached by the specified starting point and exit choice, or -1 if it's off the board. Okay, so we've got a board. So the first thing we need to do is to find out from this board, let's find out how big it is first, right? So we'll say int side equals, int side equals board dot length, dot length, and we've got to use square root because the board's going to be the square of the side, right? It's a square board. They promised a square board, so math dot square root of the length of the board string. All right, so that's telling us already the side, how long the side is. And now we have to make this an int. It's going to give us a float, so we have to force that into an int. Okay. So now we have the side. All right. All right. What else does it say? Position directly reached by the specified starting point and exit choice. Okay. So it's either going to go up or down. Now the simple way to do this, I think, there's lots of ways to do it. But one way to do it, I would just break this down into 2 cases. We already discussed this on Piazza. Someone asked how to do this. There are lots of ways to do it, but let's just do it like this. Okay, so we're going to have 2 different cases. If they're going vertical, then we're going to do one thing. If they're going horizontal, they're going to do another. They're starting at a from case, okay, and so we're going to say char piece equals board dot charat from, okay, like that. Okay, so what that's done is it's told us the piece. Okay, now we also want to know where this piece is on the board, so we can know what the row in the column is, right? So we can know if it's going to go off the board, for example. Okay, so let's say int r equals from divided by side, right? Everyone okay with that? So that's saying that the row that we're in is going to be the position divided by the side. Int column equals from integer remainder side. Okay, so now we've got our row and our column, so we know where we are in the board. Okay, and then what we're going to do here is we need to know where to go, and we're going the vertical direction. Let's do the vertical direction first. Okay, so now we've got a whole lot of cases to think through. So let's write a switch statement. Switch on the character P, and then we'll say case, and then we're going to go through these cases. What are they all? What are they called? W, X, Y, and Z. Okay, so W, I've put that in the wrong place. Case W. Okay, what's it going to do? All right, so if it's a W, let's make this bigger. You want a bigger screen here if you can. So for W, it's going to go 1 square up and 1 square left. By the way, you can do this. Where is it? Window. I'm used to using too many different things. You can split view. Is it in view? Where is it? View. Split. You don't know how to do this in IntelliJ? I use another editor very often. Split horizontally. There we go. All right, so we've got that. And now we split it in half. And what we're going to, so we can see this thing here. So we're going to say, if it's W, we're going up by 1. So the problem case there is if W is in row 0. If you go up by 1, then you're off the board if it's row 0. So if it's case W, you say return row equals 0. Depends on if row is 0, then we're in trouble. We'll say minus 1. Otherwise, we go to the position minus 1 row, which is minus the side. Okay, so it's from minus side, right? Does that make sense? And then we're going to repeat this 4 times over for all the different colors, and they're going to have all different numbers in there. What is it? Black, X, Y, and Z. W, X, Y, and Z. And let's step through each one of these carefully. So X is going to do, it's going to go 2 squares down. So if the row is greater than side minus 2, then we're in trouble. Okay? If the row is greater than side minus 2, then we fall off the board, right? Because you're going to go 2 squares down if it's anything more than side minus 2. Otherwise, you're going to add on to from 2 times the side, right? And if, like me, you always forget your precedence rules, I mean, I know what they are, but it's easy to forget in exams. So it's often good to put parentheses around there just to make yourself confident. X, what's X going to do? It's going to say, sorry, Y. We're up to Y. Y says if R, it's basically just the same. Now it's 3 down. Okay, so if the row is greater than side minus 3, then return minus 1. Otherwise, it's going to be from 3 times the side, okay? Because you're going to go down 3, okay? Like that. There, okay? And then what's Z? Z is going to go up, okay? So now it's if it's less than 1, it won't work because you're going to go up by 2, okay? So if it's less than 1, if it's less than 2, right? If it's less than 2, then you're off the board. Otherwise, it's going to be from plus side times 2. Again, you can use your parentheses if you're worried about precedence. Okay, does that make sense? Yeah, go ahead. Someone's got a question.
I'm not sure if this is correct, but I think that it should be side minus 3 on the top one and side minus 4 on the bottom one.
Where?
So with case X and case Y.
Case X, right?
Yeah, let's say side equals
4.
Okay,
yeah. So don't forget it goes, imagine it's a 4x4 thing, okay? All right? So 4x4, all right? Now, if this, don't forget this is 3, right? That's the number 3, 0, 1, 2, 3, okay? So if you're going to go down 2, so you want to say that if R is greater than 1, which is side minus, you're absolutely right. Well done. Well, or we can change that to greater than or equal to. Did everyone follow that? I was off by 1. Okay? With that number there, I was off by 1. Hopefully.
I don't think the resolution of the recording of the video isn't very good, so I can't really read everything that's going on.
Oh, where are you watching?
It might be on my because I'm on campus and the internet kept on dying every.
Yeah. It's kind of sad that the video might be better when you're not on campus. All right. Sorry, folks.
Oh, is there supposed to be 2 equals? Oh, never mind. It was just the quality of the video.
All right. Oh, and
I just couldn't read that.
IntelliJ just went and simplified all my stuff and made it less easy to read. I think it's some people don't like you doing this, but I think an example like this is actually easier to read if you format it this way. So now we're going to go horizontal, okay? So now we're interested in columns. So for W, you're going to go 1 square left. So you say if the column is equal to side minus 1, or greater than or equal to side minus 1, so greater than side minus 2, then you get minus 1. Otherwise, it's just from plus 1, from plus plus, okay?
Mm-hmm.
Right? Because you're going, oh no, you're going left. It's the other way around. So for W, you're going left. So you say if the column is less than, well, if it's 1, just say if it equals 0. It's easy, right? If the column is equal to 0, then it's minus 1. Otherwise, it's from minus 1. All right? And then for X, you're going to go 3 squares to the right. So you want to be, it's very similar to this one. You're going to say if the column is greater than side minus 4, then that otherwise times 3. Okay? And the next one is 3 squares to the left. So you say if the column is less than 3, like that, then it's going to be minus 1. Otherwise, it's going to be from minus 3 times the side. Right? Is that right? And the last one, you're going to say for Z, you're going to go 1 square to the right. So you say if the column is less than 1, or equal to 0 if you want. You can say equals 0. Then it's -1. Otherwise, it's from. Oh, it's right. We're going to go that way. Sorry, I goofed that up. If the column is greater than, if it's equal to side -1, I guess it's another way of saying it. If it's equal to side -1, then you're at the right-hand edge. You can't keep going. Otherwise, it's from +1. And this is wrong, by the way. Did you notice that we made a mistake here? It shouldn't be times side. It should just be like this. Okay, because in the horizontal direction, you're not going up a whole row. You're going across just one point. Okay, so that's also a mistake. All right, so should we give this a test? Let's try this. Where are we? What is this? Tunnels. Is it what we're doing? Tunnels. Okay, tunnels test. All right, so we'll test that. And I have to make this bigger to see what we got. Did we get anything here? We got nothing. Oh, wow, that's bad. All right, so test directly reaches, direct simple. Okay, expected 1 for that. Position 7. All right, so what's wrong with our code here? Let's look through it. Okay, so vertical equals true, so the problem is here in this case, and it's a Z, so it's this case here. Okay, so let's look at it. And what we've said for Z is that it's 2 squares up. Okay, 2 squares up, it means minus, not plus, right? That was bad, right? You see, if it's going up, it's got to be a minus sign. All right, everyone get that? So that was a mistake. Let's see if that fixes it. I don't know how many other errors there are like that. Okay, great, we're done. All right, so now we go up to shortest, the very last part. You guys can hang around. You can just leave if you want, but if you're interested, you can just hang around, and we'll do the shortest thing. Okay? Do you want to try and get through this? Should we try and do this?
Yep.
All right.
Why not?
Why not? All right. So the way I would do it is write ourselves a simple recursive method that this guy calls. Okay? So we'll say private int s, and this one we'll call ourselves, and it's going to be just, I think we can just make it the same signature as this. Okay, what we need to do, what do we have to do here? All right, and we're going to make this recursive. Okay, so what does it say? It's composed of all these tiles, and we have to return the length of the shortest path from the starting point to the end point of the board, following one of the available tunnels at each point. So at each point we can go either way. All right. So and return 0 if there's no path, or if the start and the end are equal. So one thing we can do straight away, when we get somewhere, if the start is equal to the end, then we can return 0. Okay. If it start equals end, return 0. Okay, like that. Also, if okay, if we go off the board, then we're not there either. So we want to say if start is -1, because remember the thing above that returned -1 when you're off the board, right? Yeah, it returns 1 when you're off the board. So let's just say if start equals -1, then return 0 also. Okay, that means there's no path. We're not going to get a path if we're off the board, right? We're done. We're toast. Okay, so that's 2 cases to worry about. And then probably what we want to do is we want to have something like an array of visited things. Okay, so that's what I would do is I would say Boolean visited, like that. And then in here we can initialize it. We'll say Boolean, so visited, oh, static, it's going to be static. Okay, so static Boolean visited equals new Boolean, how big is it? It's got to be the size of the board, right? So board dot length. Okay, so now we've got an array there which tells us if we've visited something, and we can mark if we've visited it or not. Okay, so what I would do, also if we're already visited this path, this point in our path, then we're also out of it. Okay, so if visited start, it means we're going back in a loop, right? Then we'll return 0. Okay, and then we're going to do some stuff, and we're going to say visited start equals true. This is just a pattern I would normally follow for writing through, for writing something recursive, you want to have a guard to make sure you don't just come back on yourself. So we'll do it like this. Okay, and we're going to do some stuff in between here. Okay, right. So that will stop us coming back over the top of ourselves. All right. So now what we need to do. So we've arrived at some node, and we've said if we're already back at the start, then we return 0. If we've already met the end, we're done. Okay, that's one of the base cases. If we're off the board, we're done. If we've already visited this point, we're done. Okay, so we've got all those ones covered. Otherwise, then the only thing left to do is to explore the alternatives, right? So we want to explore these alternatives. And if we're at a position where we've got to find the shortest path, so what we need to do is explore both the vertical and the horizontal, and find out which is the shortest. Okay, everyone with me on that? So one way to do that, you could say int v equals how would you do this? S board. This is recursive, right? So we're going to call ourselves. So we're going to call our own method on ourselves. And the starting point won't be our current starting point, because that would be bad, because otherwise we just keep going round and round and round. But our starting point will instead be the thing that's reachable vertically. Okay? So we'll say if, we'll say, what is it, directly reachable, is that method we already have here. Like that, directly reaches. Directly reaches board start. That's us. Sorry, that's where we are, start, right? And the Boolean is going to be true because we're trying the vertical one first, okay? Does everyone make sense of that? That line there is saying, here's the path from this particular one. Here's the shortest path from this particular one in the vertical direction. If we start off walking the vertical direction, this thing here will tell us the shortest path in the vertical direction, okay? From this point on, right? And then we've got the horizontal one. It's going to be the same, except it's going to be false, right? So now we have the shortest path in either direction, okay? Now, if then I think what do we have to do? I think all we need to do now is return the minimum of those, right? Oh no. If we're off the board, it's not that. It's actually going to be a giant number, right? Okay. Does everyone agree with that? If we're off the board, it means we can't get there. Whereas if we're equal, that means we got there really quickly. Okay. So we're going to return max int here. Okay. It means we're not going to do anything. Int integer dot maximum. So it's basically not getting anywhere. That's what that means, right? So we return that, okay, and then here we're trying to find the shortest. So if one of these didn't get anywhere, we'll do the same here, okay. It will return maximum, the biggest number possible, and then we'll take here. We'll return whatever is the minimum of the two, right? Plus 1, right? If it wasn't a max int, I guess. Okay, so we return math dot min of v and h, like that, plus 1, because we're at a point and we're going to go one more further to reach each of those, right? 1 plus that, unless so here shortest min int min equals that guy. There we go. So we'll do that. And if the minimum distance is max int, then we just return max int, I think. I'm just making this up, guys, as I go along. Please, if you see something that you think silly or a better way to do it, just yell. But hopefully what I'm saying makes sense. You can see how I'm doing it. So if the minimum equals max int, integer dot max int, sorry, max value. If that's what we got back, that means we're going nowhere. We can just return that. So we return integer. We can return min. Otherwise, we return 1 plus min, okay, because it means we actually got somewhere. Does that make sense? All right, let's just try this out. I think this makes sense. So let's just try this out. Board start end. Oh, and we need to what does it say to do? It says 0 if there's no path to the endpoint or they're the same. Okay, so now what we need to do is say int rtn return or something like that equals this. So we're going to call this guy. Oh, there's a missing comma there. Okay, like that. Now, what's happened here? Board start end. What have I made? What mistake have I made here? Non-static method s. Oh, I didn't declare this as static. Okay, so there we are. So now what we're going to do is say if that was maxed in, then we return 0. Otherwise, we return that value. Because if it's maxed in, it means that we never found anything. Integer.max. Right. So if it got that, it means we got nowhere. So we return 0. Otherwise, we return that value. What's the matter now? Oh, sorry, return. Okay, let's see how we go. I've got a bad feeling that oh, there you go, and we're done. Okay, hopefully do people have questions about that? Anyone have any questions? Now's a great chance to ask a question if you have one. Nope. 0 questions? No. Oh, you go ahead.
I've got a request.
Yeah, sure.
Would you be able to cover your notation with the question mark or like?
Oh, sure. Yeah, I have done that in a lecture. A couple of people have asked me about that and on Piazza, but I'll do it again. Okay. Sorry, that is a shortcut, and all right. So that's a very good question. Okay, so let me just rewrite this using that, just so you understand what I'm doing. All right, I'll comment that out. And what I could have said is this: if rtn equals integer.maxInt, max value, then return 0, like return 0, right, like that. Else, return rtn, right? That was the logic. I'm not changing the logic. All I'm doing is changing the way I've written it, right? So we do that. And we run that, and it should be exactly the same, right? Yeah, okay. So now let me do the other way, and I'll talk you through it, okay? So we'll comment that out, and we go back to here, and I'll explain it. This is a shorthand version for that, but it only works well, it doesn't only work. It works for multiple nested ifs if you want. But here what it's doing is, this part here is an expression. In fact, I didn't even need the parentheses there. Let's just make it even simpler still. Okay, so this is a Boolean expression, right? The question mark is a special operator that says whatever the Boolean expression is on the left, then do this thing, and then look for a colon, look for a colon, and do the thing on the right-hand side of the colon. If it's false, do the thing on the left-hand side of the colon if it's true. So this and this are exactly equivalent. It's just a shorter way to write it. And when I'm writing it in a lecture on a small screen, it really looks a lot easier to read, I think. I hope it's easier to read. And certainly I think that for things like this, right, if you look at that piece of code there, if you rewrote it using all those if statements, it'd be a lot harder, be a lot bigger, and I think that makes it harder to understand. I mean, maybe not. Maybe you find it harder to understand, but I think that it's even easier if you do something like this and space them out. We're not going to make it all pretty when we're actually in a rush in the exam, but hopefully you get, if I do this, you can kind of see that this makes it, if you write your code like that, so hopefully when you look at the code, when it looks like that, it becomes really clear what the pattern is, right? And you can see that we've got all these conditions in this area, all these conditions, and we're responding that way. We're going off the board in each of these conditions. Otherwise, we're doing this thing here, and it varies depending on which piece we've got. Does that make sense?
Yes, thank you.
Okay. Any other questions?
So why is it better to use the max value instead of any other? So why is it better to use max value?
Here, why did I use it?
Yes.
Okay. That's a really good question. Let me try and explain it. First of all, this question is about the minimum, right? That's just how it happens. This question is about the minimum. That's what it says. It's called shortest, right? So what's the opposite of shortest? You know, if you're doing math, if you're doing this in mathematics, in proper mathematics, you'd say infinity, right? You'd say infinity, right? If you are, if you're doing mathematics and you want something that's the opposite of the shortest, you'd say it's the biggest. It's infinity, right? You agree?
Mm-hmm.
Right. So basically, I'm using this guy is essentially infinity, right?
Mm-hmm.
So I'm saying that
Integer.
yeah, max int is the biggest number you can have, and we're kind of treating that logically like infinity, right? So if someone wants to, so that's just a way of saying it's the opposite of what you want, right? It's a maximum integer, and this thing says you've got to find the other thing without going off the board. So if you've gone off the board, then it's not the right thing. It's the opposite. It's infinity. So that's what this is. You could think of it like infinity. Does that make sense?
Yes, it does.
Okay. Any other questions? And by the way, Java has this for all the types. I've got max value for char, for double, and all those things. They all have max value, so you can use it logically the same. Does anyone else have other questions?
Thank you.
Any other comments?
I've got a question that's more related to the mid-semester exam as a whole.
Yeah, sure. Go ahead.
So just by going through the questions, over the questions that you've just done.
Yeah.
Okay, not everything is doable for me, maybe, but I do think that I could have attempted most of it.
Yeah.
So why should there be a time limit in doing such a thing? Because logically, testing whether we understood what we've learned would be to be able to attempt every question and being able to also
sure
pass the tests and all that stuff. So
yeah. So why do we have a time limit? Okay, that's a really good question. It's a really good question, and it deserves a proper answer. Okay. Sorry, did you finish your question? There's a bit of a delay here, and I don't know if I jumped in on you.
That's all right.
Did you finish saying what you wanted to say?
Yeah.
Sure. Okay. Yeah. So that's a great question. One very quick throwaway answer is, this is one way of assessing people among many. Okay? There are many ways of assessing people. We have assignments, we have all kinds of stuff, and most importantly, we have an end-of-year exam, which does not work this way, right? The end-of-year exam always is a long exam, a 3-hour exam, okay? And it's obviously a 3-hour exam examines something very different to a 30-minute exam, right? It's testing very different parts of your understanding to what a 30-minute exam tests, okay? So I'm acutely aware that it's testing something different, all right? Now, that's one point I want to make, okay? So this is only one technique. I'm not going to test you always on this sort of thing. Never. I would never do that. This is just one way among many. And in a class like this, I like to test you multiple ways, because some people will perform well this way and not in the other, and vice versa, okay? So we need multiple ways of testing people, because different people respond differently to different environments, okay? That's one point. So we want a variety of testing mechanisms. We want a testing mechanism. We don't always want to use this, for sure. In fact, we only use it once per semester. Since I ran this course, I've pretty much always had a 30-minute mid-semester exam. Okay, I think I did a 1 hour mid-semester exam once, but it's usually a 30-minute exam. Okay, but I always do a long exam at the end of semester. Okay, so that's one bit of context. Second bit of context, it's completely clear to me that in the COVID situation where everyone is remote, with a chaotic communications thing like Teams, which we are not going to use again for exams, because I think it was a disastrous communication means, frankly. So we're not going to do that again, right? But with a chaotic communication means, and with technical issues, a handful of people had technical issues. There were some people, it was actually only 8 people in the whole class of 400, but there were some people who had troubles connecting and stuff. All of those issues get expanded, get magnified, right, by a compressed time frame, right? So I totally get that doing a really short 30-minute exam, in retrospect, I shouldn't have done it for remote learning, but I didn't. This is the first time I've ever done this, right? I've done 30-minute exams all the time, but they're always in the lab. In the lab is different. Communications is much clearer because you've got a human telling you what's going on. And the environment is exactly the same. Everyone sits there in front of the same computers with the same environment. You don't do any cloning, nothing. You just open it up and the IDE is already there with the exam in it, okay? whereas you guys had to go and mess around and get your computers happy, and some people had all kinds of weird issues and stuff. Okay, so I'm not going to defend having a 30-minute exam in a remote learning situation. I simply did not know it would pan out that way. If had I known, I would never have done it. Of course, I spent a huge amount of time preparing this exam. I guess you can probably see by looking at all the questions. And I wouldn't have spent all that time if I thought it was going to be like it was, right? So I was really, really disappointed. Okay, so hopefully what I've just said to you is two things. One is that there is a place and a time for short exams, but they're never on their own. You need to complement it with other assessment techniques, such as our labs, such as our assignments, and such as a 3-hour exam. That's one thing. And second of all, doing a 30-minute exam is a really bad idea with the technology that we have at the moment for remote learning. And that was not something I knew, and but I certainly know now. And unfortunately, you guys got caught in that. Okay. One last thing is that. Oh yeah, the other really important thing, and it's a very important and valid pedagogical technique when examining someone to see how they perform when time is not unbounded. Okay, so if I said to you, look, here's some snacks, take out food and whatever, sit here for 24 hours and see how you go, right? You're going to have a different outcome to if I just say you got to do it right now and you've got 30 minutes, right? It's going to be different, and I'll be assessing different things. Okay. And there are obviously logistical problems with having a 24-hour exam or a 1-week exam if you want to take it to extremes, right? But if you give someone an unbounded amount of time to do the problem, you're testing a very different thing, okay? And one of the peculiar things with what you guys are doing is you guys have browsers available to you. You have everything available to you, and I can't even stop you talking to other people. Of course, you mustn't talk to other people, but I can't. There's nothing I can do technically to stop you. Okay, so that does color the situation significantly. Okay, so anyway, my point is that I think that there's a valid place for short exams. I think they test something important. I don't think it was a good idea to do a 30-minute exam with the technology that you all had or that we all had. In retrospect, I wouldn't have done that had I known it was going to pan out that way. Although I might have done a 1-hour exam. Okay. Which still would have put you under time pressure. And I also point out, sorry, one thing I forgot to point out to you. In some areas, it's absolutely normal to do this technique. Okay, like in mathematics. I don't know if you've done advanced mathematics, but if you do advanced mathematics, you will find that it's very, very common to sit a 3-hour exam that is impossible to finish for most people, unless you're a Fields medalist. Okay, it's impossible to finish for most people, and they're interested in doing discrimination. What they want to do is to see, okay, there are a bunch of people who could get some of it, and there are some people way at the top here who can nearly get it all out. So it's discriminating and separating the students out from those who can get a long way and those who can't. Granted, to some extent, that's testing how quick you are rather than how clever or creative you are. But that's why we have other testing means as well. All right, so that was a really long answer. I didn't want to sound defensive. I probably did. I didn't mean to sound defensive. But hopefully I gave you a bit of a sense as to why we have these 30-minute exams. And I also made it very plain to you that I'm not happy with how that exam panned out.
I think that makes sense. It covers quite a bit of information that I wasn't really aware of.
Yeah. So, yeah, look, I'm really embarrassed and disappointed how it panned out. But, I've been teaching for a long time and, won teaching awards and stuff. So I didn't do this lightly. I did it with a lot of thought and consideration. So I was really actually gutted by how it turned out because I didn't want it to turn out like that. I got stuff wrong, and I've admitted that, but it wasn't because I was cavalier, right? It was just things I had never expected before because I've never been in a situation of teaching remotely before. So anyway, apologies. Any other questions? I know we're well over our time, but I'm happy to answer further questions if you have any. All right, I'll give you another few seconds to ask me a question. Otherwise, let's call it a day, and you guys get to have a 2-week break. And hang on, someone's asking a question. Yep. No. All right. Someone's telling me something else. All right. Yeah. Question.
So, is there any course representative meeting today, or has it?
Yeah, there is. The course reps. I'm going to meet with the course reps. Although Wenhan just messaged me to say he can't make it, but I'll meet with you both. I'm really keen to hear what the course reps have to say, particularly after mid-semester exam. So we'll do that straight after this. In fact, what I'll do is I'll get everyone to leave except the course reps. If the course reps are here, and I'll chat with the course reps.
Yeah.
Okay, is everyone good with that?
Thanks.
Unless anyone has anything else, I'll get you all to leave now, and I'll just chat with the course reps.
Yep, thank you very much.
Okay. I see Linda there. I see Sean. Hey, Leo. Oh, is that, who's that? Sorry. Hang on, I'll unpin myself here. Stop. Wait a second here. Cancel spotlight. There we go. Now we'll just see whoever's here. And I'll put my video on full. So there's a few people still here who aren't course reps. Hey, if you don't mind, I know some of you may have tuned out, but I'm just going to ask you to leave if you don't mind, just so I can chat with the course reps.
And by the way, you're still recording.
Yeah, I can stop the recording if you want. You want me to do that?
Yeah.
Yeah, I'll do that. Yeah, of course. If you're going to tell me something confidential, of course. Just give me a second. I'll turn off the streaming recording first.
Oh yeah, Steve, you're still streaming.
Yeah. I'll stop that now.
Yeah.